Okay guys, tonight I am working on this 2013 BMW X3. It's got the 2-liter N20 engine, and like many of them that I've been getting, this one does not run. It actually does crank, and at times you might get it to start and it'll run for a couple seconds and then it shuts off. When it does run, I haven't heard any crazy rod knock noise, abnormal noise, which gave me some sort of confidence of possibly being timing, and then it could be rectified and no engine damage just by the way it sounded when it ran real quick before shutting off. Again, this is N20, another possible timing situation, so I don't want to overdo it. I've shown a couple or so beforehand on diagnosing. Some were kind of, the X1 comes to mind, that it was a very weird situation. So unlike this one, that one didn't crank, or it was a sort of crank. So I don't want to beat this one like a dead horse, but I decided to kind of bring you along to just show you my mindset and on the testing that I do before deciding which way to go with these. So as always, here is a shot of the codes that I got off camera the other day. And the DME has many codes. Obviously the turbo one, I'm not going to worry about. It's got diagnose, cold start, control for intake control, camshaft jammed. It does have some of these oil pressure related ones that I haven't really run into. So that oil pressure control, pressure too low, oil pump pressure too low. You have a mixture, and then exhaust Vanos ones after that. So a lot of signs of very bad possible situations. But again, being that it did crank and sort of ran, I want to do some testing before even condemning an engine. And this is probably why I decided to bring you guys along, because based on some testing and what you can find can mean the difference of replacing an engine or fixing the one that you got by finding the problem and rectifying that. So I will get you a shot of what it does. This is how it came in to me. I haven't really taken too much apart, so hopefully it'll at least start for you. If not, we'll get to hear it cranking. Okay, as far as what I am deciding to check and inspect because of the situation that I've got, are going to be a few different signals, so I'll get you a shot of that. For to begin with, I've got the amp clamp on the battery cable going to the starter, so I'm going to have relative compression. I am going to sync off coil number 1. And then here at the DME, I've got the crank sensor and both cam sensors there. And I will also be adding an oil pressure reading off of this port here. On the other older engines, the oil pressure sensor is installed there. On these newer ones, they just plug it off with that screw there, and you need this special, and you'll need this adapter. That's the BMW part number, because the threads are different and not the same of any of the oil pressure test kits that I've ever had. So I'll screw that in there to get an oil pressure reading, hoping that the oil pump chain is still intact and bringing oil pressure up. It's the same thing I showed on the last one on the X1. That gives me a good security feeling of knowing this could be potentially saved because we know it didn't run without oil pressure. Now, being that we have oil pressure codes, that is one that I definitely want to take a reading of. Lastly, I want to take a look at intake pulses, and if you look there, I unplugged that plastic hose from that port that's on the side of the throttle body, and it's the port for the evap purge. So we'll get a good reading. That's where I always tap in on these N55s and N20s to get a good reading of all the cylinders. So that is all my connections. That is what I'm gonna take and read while it cranks and shuts off. And then I'll also do a purpose crank no start to get a long extended cranking to get a good picture of everything and where it's at as far as aligned with timing, where ignition is happening, how the relative compression is looking, what kind of pulses we have, and then also how much oil pressure we're getting. Actually, what I'm also going to do after I do one, I'm going to add the in cylinder into number one also, just to take a look and see what the pressures look there as well. I meant to also show you what I use for tapping into the side of the throttle body. This is just a spare hose that I kept when doing an engine replacement job because of the same size port. This will connect exactly fit on the side throttle, and it gives me a little bit of extension to be able to tap in there. And so that works pretty well. So that's what I'll use for that. Okay, so I'm all set up, got the scope running, and I will crank it as how it came in. Let's see if it'll start and stall or not start at all. Okay, so I've gone ahead and unplugged the injectors. I'm going to do a crank no start condition and try to get it cranking for a decent amount of time. Just quickly wanted to get you actual physical measurement. It is right at 120. Okay, so I'm just going to do a quick summary here of the waveform of crank and no start that I just took. This was at the end when I took all the as much information that I could gather that I wanted to gather. A quick breakdown of the channels. Here up top in the green is your intake pulls from the intake manifold. This is intake cam. This blue one here is exhaust cam. The red is ignition 1. This purple one here is in cylinder 1. The purple one down here is the crank sensor. The blue there is relative compression. And the yellow here is oil pressure. Now, right off the bat, in big picture form, this can tell us quite a bit that's going on. First, we can start off with the blue relative compression. We can see we are making compression, and they are all pretty much relatively close to each other. This one's the only one that's a little bit lower, but that is because I've got a compression hose in cylinder 1. So we know that's cylinder 1, but they are all relatively about the same, so we are making some compression. Next is we know we are having intake pulls for all cylinders. Third, we can see that we are building compression there, clearly how we saw in relative compression, but that tells us both valves are closed at some point. At over here, pressure gets released, so exhaust valve opens. Over here, intake valve opens and closes and build compression. So this in-cylinder waveform shows me and tells me we've got valves that are sealing, opening, opening, closing, sealing, so on and so forth. So condition of the valve seems to be good. Next is we can take a look at the oil pressure. And to get a figure, because this one was the more important one. So a figure for that during cranking is right about 28, 29 psi. The fact that we're making that much during cranking tells us the oil pump chain drive module is still intact. It is spinning the oil pump. And being that we have oil pressure, we know that this engine, prior to coming here, was not run without oil pressure per se, being that this is only at cranking. Next, the other important one that I want to look at are going to be the two cam signals. Again, this one is intake, that is exhaust in the blue. And we will compare that to a known good. So this is a capture of a known good. There's your CKP. Red is intake, green is exhaust. If you look, you've got large, medium, small, large, medium, small. Concentrate on the two smalls. They pretty much line up here. One starts where the other ends. Intake is on the top. And if you look here, the small, intake is over to the right. It is not lining up where this small one ends. So what the condition is, or what is wrong with this car, why it's doing what it's doing, is the intake cam is delayed. It is retarded and causing our drivability start stall or no crank issue. So to not bore you guys too much, this is just quick, simple, gather some data to be able to make a decision of how to go forward in making your repairs or recommending your repairs. And quickly, and it is a common known thing with these engines, but when I get these in this condition, these are some of the things I like to look at, and particularly this one down here, oil pressure. That is almost a deciding factor on what to do going forward, as well as the valve condition, meaning they're not bent and in okay, or have the ability to seal as they need to. So from here on out, it looks like we'll be doing timing work and should get this up and running. So right now we got the timing tool down on the crank. So the crank is locked on TDC number 1, and then the front of the phaser wheels, you can tell that where this hole's at, and this one should line up with the tool, and these pins will go into those slots, but both are actually off. Obviously you can see that one there's not lining up, and this one also doesn't line up. And the cam, that portion there, the flat spot, it's pointing not straight up. This one's off a little bit, but closer. You could tell it's uneven, but that one the jig won't even fit, so that's where the timing is off. Okay, so just a couple things on this X3. Obviously we know timing on the N20s are prone to failure, but I've been getting a lot of them come through here, and just a little bit small piece of word or tiny rant. Each time I do these and I go ahead and pull the oil filter, number one, aftermarket. Number two, and I see this a lot. You see how the filters are collapsed, where it's coming in on itself? That is because it is too dirty, and the filter element in the filter cannot let oil through because it's blocked off, and its oil's trying to come through and it's just collapsing it. That is from too long of extended oil change. You tell people 3,000 miles, they go 5,000-6,000. You tell people 5, they go 7-8. You tell people 10, they'll go 15, they'll go 20, so on and so forth. People just are not maintaining these vehicles well, and a lot of the time components have to rely on oil. The other thing, obviously, there is broken pieces of the chain guide, so on and so forth. I believe some of the I believe some of the oil pressure codes are going to be due to the oil pickup screen had a bunch of these broken pieces in the screen blocking it. So I believe that's why the vehicle was having oil pressure codes, and obviously we know why it had timing codes. Okay, so we ended up getting the timing all correctly done and replaced, both upper chain, lower chain, so on and so forth. Let me show you what we got. It starts, runs, idles. It sounds pretty good. Normal N20 operation. But in lieu of the major repair, from basically saving an engine or bringing one back to life, not needing to replace it in true classic BMW fashion, we end up during the test drive with a drive malfunction code. And as far as what the codes are these multiple codes here. Basically, now after we get it up running and going down the road, it has no power, and it is giving us basically turbo boost codes. So now, after we get it up and running again, like I said, and saving this engine from a condition we did not know, now I get to figure out why it's not boosting. Okay, so now I will progress into checking the turbo system on this. I've done this quite a few times, but haven't been able to film it, so I will take a chance to show you guys what I do in order to test it on these, where you do have some access to be able to get some data. As far as what the system is comprised of, obviously the turbo that is down there, and then this wastegate actuator. This one's vacuum actuated. There's the line, so that has to be working and has to pull that rod in to close the wastegate. That's internal. That'll build boost pressure. Then it's the vacuum line, and then the goes to the solenoid that will provide vacuum down there, which is controlled by the DME. And then we've got vacuum that's fed to it from a vacuum pump that goes here into a little reservoir that's built onto the engine cover and then goes over to the solenoid. And then obviously turbo on the charge pipes, and then it'll feed the throttle body. There's a sensor there and then a sensor on the manifold. And so what I typically do is I will actually tap into that same line back there, the evap purge line at the throttle body, which is basically tied into the manifold. I'm able to watch boost pressure there. So I'll tap there. I will tap into the solenoid control from the DME to see if there's activation from the DME, and then I will tap into a vacuum line there to watch vacuum if there is vacuum when commanded by that, and we'll run it, and if there's command and vacuum applied there, we'll check to see if there's boost there and see if it's working, or obviously it looks like it might not be working, but we'll see either how much boost we've got there to begin with, if any at all. Okay, so I'm all set up. I've got 3 channels. Blue is going to be the duty cycle for the wastegate solenoid. Red is the one that's tapped in by the throttle body / manifold, and green is going to be the vacuum supply to the wastegate actuator. So I'll start it up. And you can see the blue is being actuated. Green acted up a little and then stabilizing. Red is staying the same. So we'll go for a test drive. And so what I want to see is if the green gets brought down, which it did right there. I mean, so wastegate is closing, which will build boost when air moves through the engine. So we want to see during acceleration the red climb up. Obviously the duty cycle is working because we brought vacuum to the actuator. So I'm going towards the end of the driveway, then I'll get out on the road to where I'll be able to accelerate a little bit hard. Okay. So I am wide open. And now the message. So I'll let off. So that's what that looks like. And we'll go back and analyze that. And so here is the waveform for the test drive. I just quickly grabbed one portion that can explain what was going on as far as when it is faulted. So channel-wise, green is going to be the vacuum supply for the wastegate. Blue is going to be duty cycle control. Red is actually tapped into the intake manifold. Now, this section here is when I attempted to accelerate a little bit harder, which is you're requesting or demanding more airflow, or basically needing this vehicle to be in boost or start to build boost. Obviously, the blue towards the bottom, we'll just quickly look. We know we have duty cycle control, so that confirms computer wiring solenoid as far as needing that portion to be operating correctly. Being that the green dropped down in that portion, and we can get you a reading. So let's say somewhere in that range, We are about 18 inches of vacuum. And with that amount of vacuum, we are pulling that wastegate closed and demanding for more boost to be built up to go towards the manifold. Now, if you look at the red trace, and I will get you a reading, we start to accelerate and demand more air, but we actually, in the red, go to about 14 inches of vacuum during, let's call it, wide open throttle. Now, this is in the intake manifold. When we open the throttle, or this one is Valvetronic, so whether it's the Valvetronic motor opening the valve or throttle body, but when you are demanding and opening the restriction uh, gate of airflow and needing air to be ingested, you will lose vacuum and pretty much be at atmospheric pressure, because that is what you are going to be connected to be ingesting air and airflow to be coming in. That on naturally aspirated is pretty much where it would be once you have the throttle open and accelerate. Until you close it, then you drop down into vacuum as far as in the manifold. Now on boosted cars, you will still do that. You'll lose your vacuum off idle, you will reach atmospheric pressure, and then at a certain point we'll cross over that threshold and go into positive pressure into the intake manifold from the turbo compressing more air and feeding it into the engine. And that's where you will read positive pressure. That is this portion here where we are asking and demanding positive pressure, but we are actually going and pulling vacuum during that portion of demand for higher volume. So we are definitely not creating any boost. We are uh, not even staying at atmospheric. We're dropping. We're not going above into positive. Wastegate is being controlled properly, electronically and mechanically, but we are not creating positive pressure. Okay, so I wanted to show you this one quick kind of crude test, but it is very legit after seeing all the data. So watch that rubber charge pipe there on the bottom. If you can catch that, but see how it collapses. So now we will do the same at idle rev up as we saw where the pipe was collapsing. Okay, we'll stop and take a look at that. And this is just, again, quick shot of that basically moment at idle where we snap the throttle, and it can just give you basically a visualization of what was going on. This was the portion where I snapped it, same here. And this is the wastegate vacuum supply again. This is the intake manifold, obviously duty cycle. Duty cycle is working properly. Let me get you a reading of the vacuum supply that we at least provide for the wastegate. So again, about 16 inches of vacuum, and let's take a look and see what happened in the intake manifold. Somewhere around that point, we are about 12 inches of vacuum at the intake manifold when we snapped the throttle. And being that there is vacuum here, and that's connected to that charge pipe that I showed you. That charge pipe is showing us exactly what we're seeing here in the pressure reading. That whole system, which actually even tells us that the system is sealed, it is going into vacuum, meaning there's a void, there's that system's not being filled, there's a lack of volume when asked for and demanded, and instead of maintaining or going up, we are, because of the loss, we are uh, creating a suction, and it's collapsing that pipe, and obviously we're not having airflow. Okay, so after last night, after checking and finding that the scope data showed everything was good, and finally seeing that charge pipe collapsing on itself, I knew that at that point it was time to move forward to checking for basically physical lack of air movement. And I removed the air filter tube, which will connect to this portion here. That's from the air filter. That's what will feed the turbo. That wheel will spin, it'll pressurize it, and it'll send it out of here. This is where that charge pipe was connected. So this morning I took off this pipe feeding the fresh air, and I was kind of expecting that wheel there to basically either have blades broken, or the wheel basically, I've seen where they split in half, and this would be on the ground, and or where this wouldn't spin or would make noise, like a grinding noise when spinning. But as soon as I did that this morning and saw that it wasn't falling off, no signs of damage, and wasn't scraping, and that it spun, I was kind of surprised and took it back. So I took a minute to try to go over everything, and it has to be a non-air movement problem. So lastly, with the turbo still installed, I decided to then drop the downpipe and to look at that wheel. And sure enough, that is the culprit. You can see it's not centered in the bore. It surprisingly has all its fins, but it's damaged. It's not centered. It's on the end of the shaft here on this end. It's obviously bent. It's damaged. It's not straight, and due to that, it's not going to spin well. So I'll try to, and it's imbalanced at this point. So there you go. You see that? It's kind of like weighted. It just returns to that spot. So it's clearly damaged. I have no idea what happened here. I have not seen this. It almost looks like towards the rear of the fins or blades there's some damage back there, but again, not 100% sure what the cause of this is. Something obviously has damaged that wheel on the shaft. So most of the time on these BMW turbos, the problem with not building boost, the biggest, most common thing that I have run into, is this wastegate flap there. When that gets pulled in from the vacuum, that closes that port, and it is able to create boost. Once that's released or opened, exhaust air escapes, bypasses the turbo, and no boost is built. What I've run into is where that wastegate, when it gets pulled in, basically the linkage and pivot point wear out, and so where it thinks it's pulled it in shut, it actually still has not seated against the housing, and it bleeds off some boost. So at that point, it still restricts air from leaving, but some does leave, and it does build boost, but not enough boost. And also a telltale sign, there is a rattle, because when that sits up against the housing and it's not flat up against it, it'll kind of vibrate because there is space there now. And so you'll hear a rattle, you'll go down the road, you get some boost, but not all the boost that's needed, and it's from a physical leak. I've not experienced this on BMWs as a problem for me, and to this one we clearly saw we had no boost at all, and there was no wastegate rattle, and there was no rattle, no wheel rattle. So it was very weird because there was no physical noise. Everything electrically was working. We just had no boost, no air movement. In the past, I have run into this situation here where you can see clearly that it came apart on the shaft. I believe this was on the cold side. This was a Moss that I did. Same thing. I can't remember if this one had a noise or not. When it came to me, obviously we can tell it made a noise. When it came apart, it hit the housing, damaged itself, but then it was kind of just sitting there in the housing on the cold side, the charged side. And this was what I was expecting to see, because on that one also, memory started coming back to me. That one was similar deal, no air, no air movement. It had pressure codes and actually also air mass sensor codes. So again, being that I basically was expecting to see this, and this morning when I saw that, and I saw that it spun, I was very, very confused and almost got worried, but I knew there had to be something here physically, because you could see on the scope no air movement, and it goes into vacuum to the point where it collapses the charge pipe. So I wanted to do a kind of very crude visualization to explain what was going on, mostly also partially as to why the charge pipe does what it does at idle when you rev it up. Here clearly we have a turbo, and this is very simplified obviously, so we can just explain what's going on. We've got a turbo, here's your fresh air duct for it, it'll compress it, and here is your piping connected to the engine, and here is the cylinder with the piston. The piston is going to travel up and down, obviously it's going to go down regardless, because the timing chain is spinning it and it's igniting and idling, and so the piston's going to come down. And when we rev it up for high demand, high air volume compared to idle, we're expecting for this cylinder to fill up. So then if the piston now swings down this way towards the bottom, it's, in a way you could think, creating vacuum. It's lower pressure, but in doing so, in a running engine, it's also expecting to get filled with air. That space, it's expecting it to get filled with air. The turbo's job is to bring in air. This is your fresh air, like air filter, and here's your your mass airflow, measuring the air. So the exhaust on the other side will spin the wheel, which will bring in air. It'll basically suck in air, compress it, pressurize it, and fill the volume of the piping and fill up the cylinder. That's the turbo's job. The reason why I knew now to go towards checking the wheels or the shaft of the turbo itself, a physical inspection or cause of the problem, because I could tell once I saw that collapsing that it was a non-air moving problem. The air wasn't taken from here, brought in, and moved into the engine. Why? Because this here, let's say this portion here is rubber and the rest say it's metal. Once this got collapsed is because the piston moved down, it made lower pressure, it was asking for air or needing air, space was greater now, needing to be filled, but with nothing coming in this way in a pressurized form, it at idle, it comes in, bypasses the fins, travels up, and goes into the engine. That's why it's able to idle normal, because it's like a naturally aspirated engine. There's no higher than atmospheric pressure needed at that point. Once you need high volume, high air, and this wheel cannot create that, this creates a lower pressure in this whole system. And obviously this being soft, because there's a deep vacuum all the way up here, this then starts to squeeze itself and collapse. That right there is 100% lack of air movement. You're not filling up your cylinder. You're not pressurizing and filling this whole piping due to no air being moved, either from cold side or hot side, broken shaft, or so on and so forth. You can have a rag here on the suction side or something blocking air movement, but being that it idled, that was unlikely. But that is what's going on. That is why it collapses. And this, again, once we saw everything electrically with the wastegate, the duty cycle, the vacuum supply, the wastegate movement, no rattle from the wastegate, everything there that controls the turbo is working properly. Then you move on to physical air movement, and at that point we saw no air movement. Another clue also is that mass airflow code. I can't remember what it was for, maybe like not enough flow, and that is exactly what it's telling you is exactly what's happening. It's not moving enough air when it's expecting to see more air, and it throws a code. So don't jump at throwing a mass airflow sensor. It's not going to cure the problem. You have to break down the codes, and you have to look at everything, see what's going on. I know this is very crude, but I hope you can understand what I'm trying to explain in a simplified form, and why we saw what we saw. So again, there's the bad turbo, and I actually do have quite a few of these here in the shop. So I went ahead and replaced it with another known used unit. Anytime I do these, especially with the vacuum actuator, I check it with a vacuum pump at the specified vacuum level to make sure that the wastegate is seating and closing tight, and that we won't have a boost bleed off problem through the wastegate. So I checked that before installing it. That checked out fine. Everything's back together. we'll get this running and maybe get some data for you. Okay, I got the turbo installed. I have not started it yet, and I will be running with the laptop. So one thing, I am going to clear the codes that were in the DME. Then I will run the coolant pump bleed procedure. One thing this reminded me, and I wanted to explain to you guys. After doing timing on this vehicle, and I've had on others, the check engine light kept popping on for a control, intake timing control, kept throwing the code. And even though I know 100% the timing was correct, done by with the tools and turned over and rechecked everything, but it kept throwing a timing control code. I swapped over the solenoids just in case, but then I remembered you have to go in here into so you got to go into service, powertrain, and then you go into the engine computer, and you have to delete adaptations there, and then it asks you 2 different adaptations that you want to delete. Most of the time, if you're doing say vacuum leaks or any of that sort, you would do F2, everything but the increment wheel is what they call. On this one, anytime you do timing work, timing chain, any of that related work, is where you go and hit F1, reset adaptations of increment wheel. Those are the crankshaft triggers, the cam triggers, the timing that it's memorized. And once I did that, went through the reset, the check engine light stopped coming on with that code. And I've had it happen with another vehicle that a shop brought to me. They did timing and it kept doing it, and I ended up resetting it and it was fine after that. So basically, I believe that say you begin to have a chain stretch, it starts to kind of remember those positions, those targets of what it's looking for the bottom and top for the crank and cam. And once you put, say, a tight chain, and it's probably those targets are a different location because it's not as sloppy or worn out, it still remembers the previous targets, and now it thinks that there's an issue. So you have to go in there and reset that memory so it can learn its new targets and where those are hitting. So it's very important for me to try to relay that to you guys. If you guys find yourself stuck in that, don't worry. As long as you know you timed it right, just reset the adaptations and it should be fine. Okay, so here goes the first startup. I'll let it idle for a minute. So quickly here at idle, we'll be able to do the quick rev to see if there's a difference. Okay, so the red is traveling upwards when the green went down. So that's right there, a big difference. We know we are building positive pressure. That pipe is now probably, that charge pipe is now not going to be collapsing. It cannot, because we moved air, we went positive. Okay, so we are out on the road, about to make our first pull, I guess. We're just lightly cruising. The red's already climbing up, so I'm just lightly cruising. So I'll give some deep throttle now. So it's definitely got pickup. But I'll make a couple runs. I'm going to put the phone down so I can do 10 things at once, and I will get back to the waveform. And so here, lastly, is a quick waveform shot of the vehicle in its good operating condition. Obviously, same channels. Green is vacuum supply, red is intake manifold, blue is duty cycle. As always, blue is always provided, being acting correctly from solenoid. As it has been, blue is still working properly and no need to look at that. The big important thing here, so during cruising, we maintain this level here, and during high demand, the wastegate gets pulled closed shut, asking for demand and positive pressure from the turbo, which we now have. To get you a quick shot. So at this point, we are now reaching about 19 psi in its good operating condition. Clearly, now that is fixed. We've now rectified an airflow problem, that void that was there, which was causing it to go negative. Now that we can fill that by being able to move air and provide positive pressure by moving more air, we are seeing that now, and everything is working properly as we can clearly see it here with the waveform. All right, guys, so this one's all done. It's all wrapped up. I test drove it quite a few miles after the test drive you saw when I was running the scope after the new turbo. Just wanted to quickly go over just everything on these N20s. If you get them in cranking no start and it's due to timing, there's very good chance you can bring them back to life and not have to replace the engine. Main thing is you want to check and make sure you have oil pressure. Check your oil filter, make sure no metals in there. And then I have not had one so far up to this point where timing has gone off and it has bent valves. They have all been able to build some sort of pressure and relieve pressure, which tells me all valves are good when the timing went out. So part of the thing was to show you to test for oil pressure, and then you can go forward with timing. And then, of course, having the trouble with the turbo on that end of the spectrum, how to test and check for either lack of boost or no boost, and some of the steps that I took for checking everything outside of the physical turbo, like the control side of it, and then also the physical turbo of moving air. And then also, if you're gonna install a used one, make sure that wastegate flap sits tight and is not loose, which will also cause boost leak problems. So enough of this. I hope you guys at least took something out of it. Thank you for watching. Hope you enjoyed it. And that's all on this one for now.